everyone, hope you all are having a great day. This is Hajra Mughal. Welcome to my YouTube channel Physics Unlocked. So in our previous lecture, we have learned that what is physical quantity and how the physical quantities are divided into base and derived quantities. And we have also started the unit of base and derived quantities. Today we are going to discuss the dimensions of physical quantities. So first of all, what is dimension? The word dimension has a specific meaning. Dimensions are physical quantities that can be measured in some way. Dimensions is the qualitative nature of the physical quantity. What type of measurement do you make? After all, making a measurement with a clock is a very different type of measurement that you would make with a ruler or a thermometer. And these sort of define our general types of qualities or dimensions. Let us see one more example. Length, width, height, distance, displacement, radius, all are measured in meter because of having the same nature, so have the same dimensions. So students, how we represent dimension? So dimensions of physical quantities are often represented by capital letters enclosed in a square bracket. So these are the dimensions of base quantities that is given in this table. So you can see the length, which is one of the base quantity. We can represent length in a square bracket with a symbol L. So this is the symbol of dimension. Mass represented with a square bracket. Within this square bracket there is a letter M. Time, square bracket T. Electric current I. Temperature theta. Luminous intensity J. Amount of substance N. So this is how we represent the dimensions of base quantity. Now, how we represent the dimensions of derived quantity? Dimensions of derived quantities are obtained by the multiplication or division of the dimensions of the base quantity from which these quantities are derived. Means whatever the formula of that particular derived quantity, you will use that formula to find the dimension. Look at here how we do that. For example, the dimension of area is L square. Now how the dimension of area is L square? Look at here. We know that the formula of the area is length into breadth, and from the previous table you can see the dimension of the length is L. Length and breadth both are type of length, means they both have the same dimension because of the same nature. So we can write the dimension of length as capital L within the square bracket, and the dimension of breadth is also written in terms of length within the square bracket. So when you multiply these two quantities, so it will become L square. So this is the dimension of area. Now see the other formula. The dimension of volume is L cube. Now just recall the formula of volume in your mind, that it is the multiplication of three terms: length into breadth into height. So when you multiply length, breadth, height, they all have the same nature, so they will lie in the domain of the length. So we can write L multiplied by L multiplied by L, so it will become L cube. Let us see one more formula, the dimension of velocity, that is LT minus 1. Now how we can find this? So you can see the formula of velocity is displacement over time. So displacement is sort of a distance that has a direction. So distance is measured in meters. So meter lies in this base quantity, that is length. So you can write the dimension of displacement is L, and the displacement of time is T. So when you take this denominator on the upside, so you can write it like LT minus 1. So this is the dimension of velocity. I've shared a table outlining various physical quantities, their corresponding formulas and dimensions. Feel free to use this resource to practice and reinforce your understanding of these concepts. If you encounter any difficulties or require assistance in deriving the dimensions of any quantity, kindly leave a comment and I will be more than happy to provide a solution. Advantages of dimensions. Using the method of dimensions, which is called dimensional analysis, we can check the homogeneity of an equation and to derive a possible formula in its unit. Dimensional analysis make use of the fact that dimensions can be treated as algebraic quantities. That is, quantities can be added or subtracted only if they have the same dimensions. Furthermore, the terms on the both sides of an equation must have the same dimension. So basically it has the two advantages. Number one, to check the homogeneity of an equation, and the number two, to derive a possible formula and its unit. So we will see the first advantage, that is the homogeneity of an equation. So to check the correctness of an equation, we must show the both sides of an equation, means the left hand side and the right hand side have the same dimension. Otherwise, the equation cannot be considered as physically correct equation. It means if both sides, means the left hand side, the dimension of the left hand side is equivalent to the dimension of the right hand side, so we can say that that equation is physically correct. That is called the principle of homogeneity of dimensions. So let's see an example. This is a famous equation, Vf equals to Vi plus At. So Vf is the final velocity, means we can use the dimension of velocity here, which we have derived in a previous slide, that is Lt minus 1, remember that. And this is the initial velocity, so again we will use the dimension of velocity, that is again Lt minus 1. And this is the dimension of acceleration, which you haven't studied up till now. So we know that let's derive the dimension verbally, like the unit of acceleration is meter per second square. So meter is L, the dimension is L, and second square means that is t square. So second square is in the denominator, so when we take it upside, so it will become Lt minus 2. So the dimension of acceleration will become Lt minus 2 and the dimension of t will be t. So look at here, the dimension on the left hand side, only we see left hand side, so it's only a velocity, so it is Lt minus 1. That's final. Now we can see the dimension on the right hand side. So right hand side has three quantities, but in with the addition it has two quantities, the velocity and the product of acceleration and time. So the velocity has the dimension Lt minus 1 and the acceleration has a dimension Lt minus 2. So the dimension of the t will be t. Okay, if you can see, if I want to solve these two t, so t minus 2 and it has a power plus 1. So minus 2 plus 1 will become minus 1. Very good. So Lt minus 1 plus Lt minus 1, and you can see these two quantities are similar to each other. So what we can do, we can simply add them, so it will become 2Lt minus 1, and 2 is a dimensionless constant, it's a number, so number has no dimension, so we can omit it, and when we omit it, it will become Lt minus 1, which is equivalent to the dimension of the left hand side. So what we can conclude, the dimension of left hand side is equivalent to the dimension of right hand side, and hence the equation is dimensionally correct. Thanks students for tuning into this video. We have covered some great content so far and we are not done yet. Join me in the next video, part 2, where we will dive into the second advantage of dimension and explore even more exciting concepts. Don't miss out. Subscribe now and hit the notification bell to stay updated.